We have essentially three types of data. One is the on-group data. The second one is on-group data that has frequency. And the last one is the group data. Let us look at the on-group data. You can see we have 5 observations. And in the first example, we have 30.95, 5.51, 96.23, 115.72, 60.25. So we have 5 observations. It will make sense to always rank the data from the smallest to the highest. Now look at on-group data that has frequency. You can see we know that we have four students who made 1 on a particular test. We have 9 students who made 2, and we have 11 students who made 3. We have 8 students who made 4. We have 7 students who made 5, and so on and so forth, and 1 person made 11. Now we look at an example of group data with frequency. You see, we know group data when we see the class intervals. We know that we have 16 to 21, 22 to 27, and from 22 to 27 we have 19 persons there. Just as we have between 16 and 21 we have 6 persons. And when we look at, whenever you see something like this, that will tell you that it's group data, and it will require a different type of formula. Again, here we now look at on-group data in detail. You can see the first thing is to find measures of central tendency. As I mentioned before, it's always important to rank the observation from the smallest to the highest. And you can see the way we ranked it. We have 6.25, 6.25, 6.37, 6.38, and then 6.40, 6.40, 6.40, 6.40, and we have 6.5 in the 9th position. If we sum it, if we add all of them together, we are going to get 57.35. Well, the mean means the average. The average is determined by taking the sum of these values and dividing it by the number of categories that we have there. We have 9 of them. So it's going to be 57.35 divided by 9. What is the importance of the mean? Well, sometimes you are told to just what is the average score or what is the average salary of a BBA. So that's another way that we communicate information. It makes more sense to my boss if I told my boss that the average score is 6.372. Instead of showing my boss some bunch of numbers, 6.25, 6.25, 6.376, and so on and so forth. So my boss now knows one value instead of numerous values. Another way that we communicate information is to look at the mode. Which number occurs most often? We know that it is 6.4, and 6.4 occurred 4 times. So we know, we don't need a formula for this, we can just look at it and we know that it is equals to 6.4 as the mode. Bear in mind that we can have a bimodal situation where 2 numbers predominate. two numbers occurs most often. For example, you can have 1, 1, 2, 2, 3, 4. So the mode here is going to be 1 and also 2. So that will be a bimodal situation. Another way that we make a decision is to look at the median. Where do you expect 50% of the people to fall into? Sometimes we want to know what half of the class did, or half of people in Texas did, or half of people in America did. We don't want to know 100% of the people. So again, we use a formula that you see on the screen. X of p multiplied by n plus 0.5. This is the formula that I will advise you to use, because this one formula is going to work the problem for you when we deal, number one, with percentiles, when we deal with median, and when we deal with quartiles. And you're going to see that in the next few minutes. But here I have taken percentile formula, which is P sub P is equals to XP times N plus 0.5. So if I'm told to calculate the median, I can use this formula because I want to know only one formula. I don't want to know many formulas. For example, since I know that 50 is what I'm calculating, is equivalent to the median, I can just say where I see P, I put 0.50, multiply by 9, and then I add 0.5 there, and it tells me that the median is actually in the 5th position, that is X sub 5. So since we have ranked the data, you must rank the data. You must rank the data from the smallest to the highest. We simply count it. If we count, we're going to see 6.25 in position 1, 6.25 in position 2, 6.37 in position 3, and 6.38 in position 4, and 6.4 in position 5. You can see we get our median. But this is not the only formula to use, but this is the one I encourage you to use because it will save you a lot of time. For example, a formula that is often found in various other books will be to say, remember when we say X sub 5, which gave us 6.4, it doesn't mean that X sub 5 is the formula for the median. It is the median locator. It locates the position of the median. When you have ranked data, when you have an ordered array, O-R-D-E-R-E-D, an ordered array of data, when you rank it, it will tell you the position where you can find the median. Also bear in mind that we can also do something like this. Since we know we have 9 observations, if I said 9 plus 1 divided by 2, that is n plus 1 divided by 2, that will give me 5. I know it is the 5th position. So we can do that. But knowing that formula does not help you when you are told to find percentiles, when you are told to find quartiles. The reason I am advocating the use of this formula is we have 99 possible percentiles, and we have 3 quartiles. So it is much better to use a formula that will calculate for me the 99 possible percentiles. I can say I want you to calculate P50, which is the same thing as the median, which is the same thing as the second quartile. So with that one formula, instead of knowing the formula for the median and knowing the formula for quartile, I just know this one formula. For example, since we can have 60th percentile, where I see 0.5 on this area, I just put 0.6 and I will calculate the 60th percentile. It will be 0.6 times 9 plus 0.5, and you can punch out what that is, and then go and identify the position on this table that we have. Now on the next material there, you see we have measures of variability. Now it's always easy when someone tells you the average salary of a bachelor degree, the median salary of a bachelor degree, the modal salary of a bachelor degree. If that example doesn't stay with you, it's always easy for someone in finance to tell you the stock price today, the median stock price. Google went up to $300 and something per share, or that I made $200 today playing stock. What is most important is the measure of risk. So risk is the same thing as variability. You hear in finance we talk about risk and return. Risk is very important. So variability is the same thing as risk. Very, very important. How something varies from one another is much more important. You can see an example. Most people tend to put their money in the bank closest to their home. Why? Because most people are risk averse. They don't want too much risk. If you want to make more money, then you can put your money in stocks, which is far away and inaccessible to you. You cannot get your money when you want it. So one measure of variability is the range, the smallest number minus the largest number. Another measure, and we're not going to pay attention to the range now. We have addressed it in the class notebook. Another measure is the average deviation, and another measure is the variance, which we are going to examine now, and then another is standard deviation. So all of these are measures of variability. So we have the range, the average deviation, we also have the variance, we have the standard deviation, and we have the coefficient of variation. And I'm going to try to tie all of those material for you. Now you are going to see the first I have posited a very easy formula to use. Everything I do, I love to use easy formula. You can see we rank the data, we started squaring them. When we squared the numbers, we get the first thing there. We get 365.4963, and that becomes the value we are going to dump there. How many observations we have? We have 9 observations. How did we get 57.35. Well, we saw that when we calculated the mean, and the mean there will be 57.35 divided by 9. But here now the formula says take the sum of x. So I just take 57.35 squared, which means something as 57.35 times 57.35. And then I divide it by n. First of all, you need to do n minus 1, so it's going to be 9 times 8. And then when I punch out, I will get 0.006169. This number is my variance, and I'm going to talk some more about it. If you take a square root of this variance, you are going, and remember now I didn't say the square, I said the square root, the radical sign. If you take that, you will get the standard deviation. Now notice that the range, the first measure I mentioned, is not very good, but it is one of the things we use in making a quick decision. If you look at the lowest value and look at the highest value, you subtract high minus low, that will give you the range. But the range will ignore in between values. It ignores in between values. So it is not a very good measure because it ignores middle values. The average deviation is good, but once you use that, it creates more problem. It no longer allows you to mathematically manipulate the data further. The variance is when you get all your statements from investment companies. They talk about the variance, they talk about the standard deviation. The variance is one of the best measures, and that is why we are discussing that here. But for exam purpose, I would like the student to know, if I said name the measures of variability, I want the student to know that there is range, R-A-N-G-E, there is average deviation, there is variance, there is standard deviation. You see, the variance is good, but the variance is always in squared units. That is why you see S squared. So if we punched out that, we really, if this was age of students, we're going to have age squared. So that's not a good measure. It doesn't tell me, it's a good measure, but it doesn't tell me more. But when I take the square root of that, it becomes, I can now talk in terms of the age of persons. Then that is the best measure in terms of the original units. Now, suppose if you have Walmart in Japan versus Walmart in America. Walmart in Japan uses yen. Walmart in America uses dollar. If I calculated the standard deviation of Walmart in Japan, it's going to be in yen, just like the variance is going to be in yen squared. If I calculate the that of US, that is the standard deviation, is going to be in US dollar. If I showed the variance, it's going to be in dollar squared. Therefore, it makes sense for me to report the thing in terms of the original units, and the original units will be the standard deviation. So now I will have the yen, the standard deviation of yen, and the standard deviation of US dollar. I cannot compare the two because they are not in the same units. It will make more sense if I use something called the coefficient of variation. The coefficient of variation. And why did we not show the formula for this? The coefficient of variation is simply take the standard deviation divided by the mean. So I will take, if I want to compare apples and oranges, it makes sense to take the variation for Japan and divide it by the mean of Japan, and take that of US, the standard deviation of US, and divide it by the mean of US. When I get the two values, then I can compare them. I can now say, oh, I think Japan varies too much, and then US does not vary too much. If you understand statistics, you don't want something that varies too much. Today you make $20, the next day you make $0. Another time you make $100. Another time you make, they even come to get your money from you. So we want variability to be reduced. So the one that doesn't vary too much will be much more acceptable to the community or society. Again, on this, you see the same things, the standard deviation I mentioned before. This standard deviation simply means take the square root. You can see the radical sign there. And then once we do that, we get 0.078546. And then you can see average deviation. Average deviation, to do that, just look at the formula. You need to first of all calculate the mean. The mean is given as x bar. So once we calculate the mean, then we go 6.25 minus the mean, and we get that 6.25 minus the mean, we get the last column. 6.37 minus the mean, we get the next column. And we keep on doing that until the end, where we have 6.25 minus the mean, and we got 0.1278. After we get that, now notice the denominator. The denominator is n. It's not n minus 1, it's n. So we divide it by n, and we get 0.000222. That's another measure of variability. But as I mentioned earlier, such average deviation is not as good as the variance, because average deviation changes the character of the data. The character of the data is changed. On the next one, we pick on the percentile. Someone says calculate the 25th percentile. But instead of saying 25th percentile, in the exam, the teacher may trick the student and say, calculate the first quartile. Well, the student is supposed to know that the first quartile is the same thing as P25. Remember the formula I said we should know? That is x of P times n plus 0.5. So since if I know that first quartile is the same thing as P25, I just put 20.25 times 9 plus 0.5. It tells me to go to a position of 2.75. and then I go, first of all, I do position 2. Position 2 will be 6.25. You can see 2.75 is in between 6.25 and 6.37. And we show you how to punch out there, and we get 6.34. The same thing will apply even if we said find P75. P75 just means where you see 0.25, make that 0.75 and punch out, and then you get the same value. This is something that you need to memorize. The first quartile means the same thing as the P25. The second quartile means the same thing as P50. The third quartile means the same thing as P75. But observe that the median is the same thing as, when somebody says the median, they are really talking about the second quartile, or they may be talking about P50. And bear in mind, the reason we are using the formula that I recommended is this formula will allow you to calculate any of the 99 percentiles. And once you know that we have 99 percentiles, and you know this, what you see on the screen right now, you can go and calculate anything using the percentile formula. Again, here now we go to on-group data that has frequency. You see, for example, here we have 24 persons who made -4. We have 56 persons who made -2. We have 33 persons who made -1, and 17 persons made 0, and 18 persons made 8 persons made 1, and 2 persons made 3. So if I'm told to find the mean, you can see now we change the formula. If you compare this formula to the first formula we saw, there was no F. So I bring in F into the formula. I need to create the third column, F times X. -4 multiplied by 24, and that will give me -96. -2 times 56 will give me -112. The other one will give me -33. And the other one will give me 0, and the other one, 1 times 8 will give me 8. 3 times 2 will give me 6. So I punch out. If I punch out, I will get -227. Now, this is very interesting. We need to look at the second column, the sum of F. The sum of F is 140. So 140 divided into -227 will give me -1.6214. And that is our mean. Now, bear in mind also that to calculate the median, we need to have something called the cumulative frequency. And it's very easy. We have 24 persons in the first row. We add it to the 56 persons in the second row, and then we get 80. We add 24 plus 56 plus 33 will give me 113. Or you can say 80 plus 33 is going to give me 113. So my job then becomes, I want to calculate the median. Then the median here is going to be the sum of F plus 1 divided by 2. Remember, it's not the median, it is the position of the median, where the median is supposed to be. Remember, this is group data. This will be the type of census data if you have ever looked at it. So we have the sum of f is 140, 140 plus 1 divided by 2 will give me exactly where I am going to. I'm going somewhere that is 70.5 miles. 70.5 miles is in the second row because we have 24 in the CF column, and then that 70.5 will be part of this 80 that you're looking at. And then we go and pick off the x value there. And that tells me right away what the median should be. The median for this data is not 70.5. It is -2. It is -2. That is the median. And we write 70.5 there to illustrate what one has to get. Again, we do further illustration. Since we want to get 70.5, we show you another way of doing it, a much more punishing way of doing it. You can do, we said we have -4, and then we count how many persons. I think it was 24 persons that have -4. And then after doing that, we start counting. We are going to find out that we are going to get -2 as our answer. You can see another dramatization of that. We start with -1, -4, -4, -4, -4, -4, -4, -4, and then we do that up to 24 times. Then we start -2, -2, -2, -2, and we do that up to where you see 80. And then if we want to find 70.5, we see that 70.5 must be associated with -2. Again, we just do this for illustrative purposes, for the student to see that we have used the cumulative method to make it much easier. You don't need to, this is just to make you learn or understand what we are doing. Again, you can see we show the work again on the next page. We see cumulative frequency. We have 24 persons there, but we are going to 70.5. 70.5 is part of 80. And this 80, 70.5, is associated with -2. And that is how we get the value. The mode, the number that occurs most often. If you look at this data, you are going to see that we have if we look at the frequency column, if we look at that frequency column, we are going to see that we have more persons in the second row. We have 56 persons in the second row. So these 56 persons made -2. So we have more persons who made -2. Therefore, the mode will be, you just look at the F column. That is, F is the number of persons. Like in the first row, we have 24 persons who made -4. In the second row, we have 56 persons. That is the most number of persons. So that makes the mode to be -2. And then here we talk about the range, and you can see the smallest value is -4, the largest value is 3, and therefore we find the range to be 7. So again, this is measures of variability that we talked about before. Then we show what we have this in the book also. How do we calculate the on-group data variance, the variance for on-group data? And you can see there are many ways of doing it. I've just chosen the easy one. I chose the last column. The last column is 667, and then you can see that represents the first value after the n. Then the sum of f times x is going to give me -227. If you square that, you get the numerator on the right hand side. Since the formula says n times n minus 1, that will give me 140 minus 1 multiplied by 140. So, and we wind up with 2.151. Okay, you can see we have used this formula, and we have calculated the standard deviation, as I mentioned before, which is simply take the square root of 2.151, and that will give us 1.4664. Now notice there are other formulas to be used that I don't want you to pay attention to, but if you were using different textbook, you are going to find it, because authors of textbook tend to write something to make it bigger so that you pay more money. And you do know that if someone took 298.921 and then divided it by 140 minus 1, then we still get the variance, and then you take a square root of that, and that will give us 1.4664. So there are so many ways of skinning the cat. If we wanted to find the average deviation, we just take 156.572 and divide it by 140, and that will give us the average deviation. And all these things are explained also in the class notebook. You can see on the next page we did the same thing. It's the average deviation that I just mentioned a few minutes ago, and it is simply we took column number 4 and we divided it by 140, and we get 1.118. That is our average deviation. Again, now going to the group data. That is the last type of data I mentioned earlier. As I said, we have in statistics, you have many ways of calculating something. Here I have chosen the easiest formula, the one that you don't have to think to do. And here in an exam you'll be given classes and F. So you know that between 4 and 7 we have 5 persons there. Between 7 to 10 we have 8 persons. Between 10 and 13 we have 6 persons. Between 13 and 16 we have 1 person. And on the whole we have 20 persons. So when given something like this, the first thing you want is an easy way. If you decided to follow my method to calculating the mean for the group data, you are going to find that we have easy formula. The easy formula is to just pick a midpoint. You can see here I just decided to work with row ROW, row number 3, and I created a D column. It could have been J, it could have been H, you can name it anything. I just picked D, and I set that equals to 0. And anything above that is -1, -2, and anything below that is 1. And then I multiply. I do 5 times -2 will give me -10. And then I do 8 times -1 will give me -8. 0 times 6 will give me 0. 1 times 1 will give me 1. And then I will have -17. Then the next important thing is, having got this -17, looking at the formula, you see it says divide it by the sum of f. You can see the sum of f is 20. So I write that. And then it says, which midpoint did you choose? You can see the midpoint I chose is in the 3rd row. And how did I get that midpoint? It is the lower limit 10 plus 13, which is the upper limit. I divided it by 2. That gave me 11.5. And that is why I wrote 11.5 there for the midpoint chosen, the midpoint I chose. Then the next thing is the CW. In the CW, it is better to look at the first row and the second row, or what we call the lower limit. Lower limit sub 2 minus lower limit sub 1. So I will say lower limit sub 1 is 4. Lower limit sub 2 is 7. I say 7 minus 4, that will give me 3. And then I punch out, I get 8.95. That is how I calculate the mean. Now, there will be other ways of calculating the mean. For example, if you want to punish yourself, you first of all do 4, you take the first row, lower limit is 4. 4 plus 7 divided by 2 will give you 5.5. 7 and 10 plus 10 will give you 17. Divided by 2 will give you 8.5. 10, 3rd row, 10 plus 13 is divided by 2 will give you 11.5. 13 plus 16 divided by 2 will give you 14.5. Then after having this f and you have a column x, then you may go and multiply f times x. So it will be 5 times 5.5, 8 times 8.5, 6 times 11.5, 1 times 14.5. You see, you are killing yourself. My method is very easy. You just pick a midpoint and set it equals to 0. And we explain fully in the class notebook how to do that. And you can see also if we want to pick the median, the mode means where do you have the most number of persons. Well, we have 8 in the second row. This 8 in that second row, the mode is not 8. It just helps me to identify the mode. The mode will be 8.5. That is the L, the lower limit, that is 7, and the upper limit 10. If I add them together and divide it by 2, I will get 8.5. So my method saves you from having to do all kinds of calculation. You see the same thing when we deal with the median. The median for the group data. Now, this one formula alone is going to, like the formula we saw before, x sub p times n plus 0.5. We used it to work all the median, the 99 possible percentiles, and the quartiles, 3 quartiles. This one formula alone. The same thing is what we're going to do here. We're going to use this one formula, and we're going to make it to become our percentile formula. And then wherever we see P, if the problem says to find the 50th percentile, we know, 50th percentile, that's the same thing as the median. Oh, okay. I don't have to worry about the median. I just worry about 50. I dump 50 right there. 50 times the sum of f. Sum of f is 20 divided by 100 minus CF. CF is 5. And then I divide the whole thing by 8 and multiply by the class weight. And that will give me 8.875. Now, again, the same concept of the range, the highest minus the lowest. So again, 14.5 minus 5.5, and that will give me 9. The other one, we want to calculate variance. And variance, again, we have shown a bunch of examples in your book. But here, to make the calculation very easy, I just pick a midpoint. I notice I pick the second, the third row, and I label that as D if I work with D first. Here I showed one example. Now, somebody could have chosen to set 7 to 10, the second row 7 to 10. You could have put 0 there and minus 1 on top, and then 1 through 1 to 2 in row 3 and row 4. You get the same answer, and I shown that in the class notebook. And once you do the calculation and look at the formula, it says D squared times F before you sum it. So you go to that column, you see 29. And then D times F. Sometimes we use F times D or D times F. D times F is the last column, and that is negative 17. Negative 17 squared, and then divided by, it says n times n minus 1. Well, what is n here? N is the frequency. That is 20. It's going to be 20 minus 1. Therefore, it's going to be 20 times 19. And then notice we have 3 squared. Where did we get 3 from? The CW, L sub 2 minus L sub 1. You can see L sub 2 is 7. L sub 1 is the lower limit, and therefore that will give us 3. And that 3 it will give us 9. So when we finish, we multiply that quantity by 9, and that will give us 6.892. Now bear in mind that we don't that this is a situation where we have no gaps in the data. You can see when we go from 4 to 7, 7 to 9, so there is no gap between 7 on the first row and 7 in the beginning part of the second row. We're going to see a situation where we have gaps in the data. Again, here we have the standard deviation, which simply is the square root of that observation. And here is the average deviation. We've talked about this before, so we don't need to revisit it. You can see all you are doing is you have to find the mean first. And the moment you find the mean, then you go and punch out the values.